Now you'll hear from the author of the low-cost photovoltaics arrays from space topic.
Photovoltaics have been powering spacecraft for over 60 years, and there have been huge improvements in the amount of power that can be generated for a given cell. Unfortunately, they're really expensive, over 100 times more expensive than terrestrial cells. This topic aims to develop technologies and processes that will bring down that cost. Starting with the materials that go into making the cell, to processes to fabricate devices and arrays into cells, and going all the way to how we test and use the cells in space, we're looking at ways to reduce the overall cost. Between NASA, other government agencies, and the commercial spacecraft industry, the need for photovoltaic systems is growing. We've seen a large number of constellation systems being deployed for low Earth orbit, seen many new geostationary communication satellites being launched, and at NASA, we're using solar-powered spacecraft all the way from close to the sun all the way out to Jupiter. On top of that, Artemis, NASA's mission to explore the lunar surface, will be using solar power for many components, including Gateway and the Human Landing System. It's obvious that both NASA and the commercial spacecraft industry would benefit from having a lower cost photovoltaic system. Some potential solutions may be novel ways to reuse or replace the cell growth substrate, to improve the throughput in cell growth, to increase yield during metallization and processing, and even to improve the way that the cells are integrated into arrays. But these are just a few examples. We want to hear from you. We want to hear your ideas on how to meet this challenge. This program isn't limited to just organizations that typically produce photovoltaics. Everyone is welcome to propose concepts that will help meet the end goal of a lower cost photovoltaic system.
Space-grade photovoltaics are very expensive, orders of magnitude more expensive than terrestrial, meaning that photovoltaics that's developed on Earth. However, as you can see, as I spoke about in the first example, the commercial space industry is booming, right? It's growing really fast. We want to privatize space. Even for us, for a NASA perspective, with us putting more assets in space, we need that solar power for habitation, but we also need it for transport, right? Currently, I think we're only getting about 20% or 20 to 30% if transmission efficiency, meaning the energy that we receive, we're only getting the 20 to 30% of that to our actual assets for power distribution, and really that affects long-term sustainability, whether we're talking about Moon and Mars. And so I think for this example or for this topic, you can clearly see the mutual benefit of NASA funding technologies that will help or advance our technologies in photovoltaics, but will also bring a lot of just really awesome technologies here on Earth. I mean, we want to see solar powered cars. We want to see more efficiency in our solar panels. As you can see, the electric vehicle industry is booming. So we want to have a lot more solar power capabilities. And these technologies that are developed for space applications can obviously be of a tremendous benefit for Earth.